Hello students, welcome to Jupiter Academy. Today our topic is vector and we will see resultant vector also. So first of all, you should know what are vectors. Vectors are those physical quantities which having magnitude as well as direction. And what is resultant vector? Resultant vector will give you the result of, or we will say it is a combination of two or more vectors. It will tell you where your final force is going on. Understood? So let's discuss what is resultant vector. We will see resultant vector when two vectors are parallel, anti-parallel and they are acting at a certain angle. Okay, so let's start our class today. Resultant vector. Resultant vector. Okay, fine. So for finding a resultant vector, for two vectors which are acting at some angle, we will use triangle law of vector addition that I will tell you in today's class. So come here students, when I will draw you will understand A vector and this is a B vector. Okay, these A and B vectors are parallel to each other. So what will be the angle between parallel vector? You can see clearly angle between two parallel vector is 0 degree. Fine. So what will be the resultant of these two vectors? They are acting in the same direction, right? And they are parallel to each other. So combination of these two will be A plus B vector. And we will get one new vector, that is your C vector. Okay. I gave one new vector named C vector which will be the combination of these two vectors. Fine. C vector will also go in the same direction as A and B are going. Suppose your A vector magnitude 10 meter and your B vector magnitude 5 meter. So resultant of both will be C, means C will have magnitude 15. Okay, then C having magnitude 15 and going in the same direction, we can say in positive x direction. If these two are anti-parallel, opposite or negative vector, whatever you want to say, you can say. If these two are anti-parallel, suppose A is going in positive x direction, B is going in negative x direction. So what will be the resultant you will get? You will get resultant here C vector, whichever is having magnitude greater. From that vector we have to subtract small vector. Okay. So here you will get a subtraction of two vectors. Fine, here you will get addition of two vectors. This is the scenario when angle between these two vectors is 180 degree. Fine, here angle is 0 degree. Now we will see resultant of two vectors when they are acting at an angle of theta. If it's 0 degree, we will add them. If it's 180 degree, we will subtract them. If it's some another angle like theta, then what we have to do? That we will do from triangle law of vector addition. Triangle law of vector addition. Let's start this. This will give the resultant of two vectors which are acting at some angle. Suppose that angle is theta. So your A vector is this. Your B vector is this one. Fine. Okay. Now what will be the angle between two vectors? Students, you should have focus here for some important points, like how you will find out angle between two vectors. Okay, angle between these two vectors, you can see here two scenario. One is greater angle and one is smaller angle. So you have to take small angle. So theta is the angle between these two vectors. Okay. Now listen, one more concept I will tell you here. What is in order and opposite order concept? Suppose you know this is a vector. This is the tail of the vector. This is the head of the vector. Right? If another vector is here, like this is A, this is B. What is the tail of B vector? Tail of the B vector will lie here and head of the vector will lie here. When tail head are in one series, then we will say vectors are in order. Then we will say vectors are in order. What will be the opposite order? Opposite order means B vector coming like this. So where will be the what will be the location of tail of B vector? Tail is here, head is here. When head are coming together means these two vectors are in opposite order vector. Okay, I told you this opposite order and in order because in this derivation I will use this both word, in order and opposite order. Fine. Okay, let's start. So when two vectors are acting at some angle and they are in order, when two vectors are in order acting at some angle represented by the two sides of the triangle, fine, then the resultant of these two vector will be represented by the third side of the triangle. What will be the third side of the triangle is this one. The resultant of these two vector will be represented by the third side of the triangle which is in opposite order. Now see opposite order. This is your resultant vector. Head are coming together and tail are coming together. So R is in opposite order and A and B are in order. So how you will find out R here? This is the condition. And I am asking you, we have to find out resultant vector of two vectors which are acting at some angle. So you have to find out R. Let's start this derivation. Fine. What we can do? First, let me draw this NEET. It should look like this. Suppose this is P point. They are meeting at P point. We will draw one perpendicular on this axis, on this vector we can say. So this is suppose PQ and suppose this point O. Fine. Okay. Can you see triangle PQS? Can you see triangle PQS? It's looking like Pythagoras theorem. If you know Pythagoras theorem, you can easily find R vector. Okay, how? In triangle PQS, this is a right triangle. So by using Pythagoras theorem, PS square should be equal to SQ square plus PQ square, right? PS is your resultant vector. What is your SQ? What is your SQ? It is a combination of SO plus OQ. What is PQ? PQ is the perpendicular. Fine. Now, you already know what is SO. SO is A. OQ is unknown. Let it be. PQ also unknown. So how you will find out OQ and PQ? Okay, come here. You see this small triangle PQO. Small triangle. I am talking about this small triangle now. What is sine theta? What is sine theta? Perpendicular by hypotenuse. Everyone know. So PQO. What is the perpendicular? PQ. What is the hypotenuse? PO. So sine theta will be PQ divided by PO. And what is PO? PO is B magnitude. So I can write here B. So I got my PQ equal to B sine theta. Okay, now fight for OQ. Now we have to find out OQ. Now angle is touching OQ, so I will use here cos theta. What is cos theta? Base by hypotenuse. What is base? Base is OQ. And what is hypotenuse? Again the magnitude of B. So I got my OQ equal to B cos theta. Fine. Now I got my variables or unknown quantities r equal to a plus, instead of OQ I can write b cos theta, plus instead of PQ I can write b sin theta. Open this bracket first. You can pause your video and you can solve also. It will be a plus b whole square formula, you should know. A square b square plus 2ab. Okay, what is the formula for a plus b whole square? A square b square plus 2ab, right? Here one cos is extra, so adjust that also, don't forget. What is the square of this? B square sin square theta. Now a square plus, can you see this b square cos square theta plus b square sin square theta. If I take common b square, what I am remaining inside? Cos square theta sin square theta plus 2ab cos theta, right? This is a mathematical identity. Okay, when angles are same and this cos and sin are square, so instead of that you can write 1. So you get your r square equal to a square plus b square plus 2ab cos theta, right? Now I don't want r square, I need just r. So we can remove this r square and put here 1 square root. This is your resultant vector of two vector when they are acting at a particular angle. Fine? Okay class? Okay, now we know resultant of two vector when they are acting at a particular angle. Suppose if two vectors are parallel, I started my class with parallel, right? If two vectors are parallel means theta should be 0 between them, right? And we will use this formula. What is cos 0 degree? It is 1. Now see what is the resultant we are getting here. So r equal to under root of a square plus b square plus 2ab cos 0. And what is cos 0? 1. Replace this. So it will be a square plus b square plus 2ab into 1. No need to write 1, right? Can you see what is this? A square plus b square plus 2ab. It is the a plus b whole square. So it is a plus b whole square under root. Now under root will cancel this square and resultant of two vectors which are parallel will be a plus b. Fine, we started our class with this only. So this is the proof. Second case, when two vectors are anti-parallel or they are acting in opposite direction. Means in short, I can say when two vectors are acting at 180 degree. Fine. So what is cos 180 degree? You know this, students, cos 180 degree is -1. Again replace. Instead of cos theta, we will replace 180 degree, cos 180 degree. So a square plus b square plus 2ab cos 180 degree. So what is cos 180 degree? -1. So write this, a square plus b square plus 2ab. Not 2a plus 2ab, it's minus 2ab. What is this? A square b square minus 2ab. It is square of a minus b whole square, right? So r will be under root of a minus b whole square. Square will cancel this under root, so resultant will be a minus b. That's why in starting I told when two vectors are acting in opposite direction, their resultant will be subtraction of 2. Okay, now see third case, when two vectors acting perpendicularly means theta is 90 degree. And what is cos 90 degree? What is cos 90 degree? You know this very well. Cos 90 degree is 0. Replace r equal to a square plus b square plus 0. Cos 90, 0. So if two vectors are acting at 90 degrees, their resultant will be this. situation will look like this. This will be A, this will be B. They are acting at 90 degree. Their resultant force or resultant vector will go in this direction. This is the case for when two vectors are perpendicular to each other. Okay, students, see you in next class. Yes, students, if my video is useful for you and it's helping in your study, like my video, comment there if you are having any doubt, and don't forget to subscribe. Bye-bye.